Hi everyone, welcome back to my channel. If you're new here, don't forget to like, subscribe and hit that bell button so you'll never miss fresh content. Today we go through my Rust implementation for the day one challenge from this year's Advent of Code. For those of you unfamiliar, Advent of Code is an annual coding event where developers solve daily challenges through December. It's a great way to practice your problem-solving skills with unusual challenges. Let's jump straight into the problem description. We have text input that consists of two columns of numbers, so basically two lists of numbers. For the part 1, we need to parse the input and then pair up the smallest number in the left list with the smallest number in the right list, then the second smallest in the left list with the second smallest in the right list, and so on. So we need to do it for all the numbers. After we have our pairs, we need to calculate the distance between the numbers in each pair and then calculate the sum of all computed distances. So first we need a function that will parse our data in some more usable format instead of string. So I decided to output two vectors of E64 integers. So the first vector is a list for the left side and the second vector is the list for the right side. How I do it is I read the lines to a variable, then create a zipped list object. So it's basically an iterator with tuples as elements. So each tuple represents the value of a number from left and right side. I check also the split of two values. So I split it and check if there are really two numbers. If not, the program aborts the execution. And yeah, after it, we unzip the list, the iterator. So we output two vectors out of it, and return the value. So for the first part, I created a function, SumLists. It takes in a reference to the vector for the left list and the right list, and it outputs the sum of distances. So we check first that the left and right list is the same length. We do a sort on the left and right list to get the smallest number at first in order on both sides. Then we combine the list with a zip iterator. So we have the corresponding tuple of the smallest values, and then we run a map on this iterator to calculate the distance by doing the subtraction from one element and another, and we take absolute value. So we don't want to have a negative value, we want to have a positive value because there is no negative distance. And after we map every value to a distance, we sum everything up. So we have a result as I64 at the end, and we output the result for it. We can test it with the list left and right as example prepared, and we can pass the lists in the function that we discussed, and the output should be 31. So if you run this, it needs to compile first, and the output is correct, the test passed. For the part 2, we still have our two lists of numbers, but this time we need to look up how many times a number from the left list appears in the right list. If we have all the occurrences for each number, Then we need to multiply it with the occurrence count and sum up all the results to compute our answer for the part 2. For the second part, I created a new function called count and sum. It also takes the two lists as in parameter and outputs I64. I also check the length at first and sort the values. Then I create a hash map to store the frequencies of the numbers. So I have a for loop to go over the right list. And if I get a value in the map, so if the entry already exists, I want to insert it by increasing the current value in the hash map. So if we have a value in the hash map with the key, for example 1, and there is a count 1, we increase this count to 2. And if there is none, we create a new entry in the hash map with a key 1 and count 1. So basically this represents the occurrences of each number in the right list. So in the actual implementation of the sum, we iterate over the left list and we map each value by getting the stored occurrences in the hash map. And if we get a value from it, so if the key exists, we take the value of the left list, it will be entry, and multiply it with the occurrences count from the hash map and return that value. And if there is no key representing the occurrences, then we return 0. So basically occurrences 0 times the entry is 0, so we directly can return a 0 as a value and don't need to do multiplication or whatever. And at the end, if we have all multiplications in the map, we can sum it up with sum and return the value. To test everything, I have two functions for part 1 and part 2. It uses internally the functions that we discussed. So this part 1 uses sum lists and part 2 uses count and sum. And if I run this, you can see the values. So that's how I solved the challenge in Rust. If you're tackling Advent of Code, let me know in the comments how you approach this problem and if you used Rust or another language. And if you want to see more Advent of Code challenges in Rust or other languages, leave a like and tell me which day's challenge you'd like me to tackle next. Until next time, keep coding and happy holidays.